I say this video is, in your own words, fully explain your coursework titled Design and Implementation of a Real-Time Temperature Monitoring System using Arduino Microcontroller. Now, you know, our coursework for this semester is on car counting system. That's our coursework for this semester. So this is a past question. So saying that it say explain your coursework, this is not our coursework. This is the one for the, I think, the last two sets. So of course, so we'll just work with this one. Of course, our own coursework, of course, we've practiced it. Okay, so I'm not making a video on that one. If I had enough time, I would have done that, but let me just finish the past questions. Okay, so and then hopefully with this understanding, we can also do any similar questions to this. Now, this particular one, design and implementation. Remember, we are doing what? Explaining. Fully explained. Fully explain. Okay? It's almost like that discourse you talked about, but this one is fully explain. Okay? Fully explain. So what are we going to explain? We are explaining what the design and the what? The implementation. Designing and implementation of what? A real-time temperature monitoring system. Don't worry about this real time. Real time just means as the temperature is changing, the the output is also changing, like almost instantly. Okay, it's 0.00 seconds difference, or seconds difference of like, okay, but the as the input or as the temperature is changing, the output is also changing. That means we are reading what the temperature is. Input output is very fast. Let me just put it that way. So what are we designing and implementing? A temperature monitoring system. Okay, and that temperature monitoring system we use what? Arduino as a microcontroller. Okay, so of course, like I said in the other videos, we are working with what pattern? Input, process, and the what? Output. So what's going to happen now? What's going to happen now is this. Now, first of all, let's explain what this thing means. So the design and implementation of a real-time temperature monitoring system involves what? The use of a temperature sensor. Now, let's just quickly do this so that you understand what I'm reading out. Now, for the input is what? You need something to monitor the temperature. So it will sensor. It will sense the temperature. Are we together? It will sense the what? Temperature. And then this processing unit needs something to what? Process the temperature. So a processing what? Units. This is where we have, okay, then of course output, something to do what? Display. Okay, so for the input, what do we have? We want to detect temperature, right? So we need a what? A temperature what? Temperature sensor. Processing unit, we've been told in the question that we are using what? Arduino. What is your handwriting there? What was? So we are using Arduino. Okay, as a microcontroller. Then for the display unit, we need something to display. The most common display, and for the assets, if it's something we did in our coursework, we will know what we use as our display, right? But this one, we didn't do this particular one as our coursework. But of course, it's the LCD, which is what? Liquid, can I write that here? But liquid crystal display, that's it. Okay, liquid crystal display. So these are our major components: input, process, output. So let's continue. Now, yeah. So the design and implementation of a real-time temperature monitoring system involves the use of a temperature sensor as the input device, Arduino microcontroller as the processing unit, and liquid crystal display (LCD) with buzzer and LEDs. These two guys are not really necessary. Okay, the buzzer will just like buzz if the temperature is really high, it will make noise. The LED will turn on. Liquid crystal display displays the temperature for us to see. Okay, just that if you are not paying attention, if you are not looking at the display, and the temperature gets to a level where it's not really good enough for maybe whatever you maybe it's not, the temperature gets to a point where you don't want it to be for your system or for whatever, then the buzzer will do what? Will turn on. In that way, even if you're not looking at the screen, you will know that the temperature is that high, and then you can take measures to adjust things and make things the way you want them to be. Okay, or take certain actions. So the buzzer and LEDs as what? Output units. So we have LCD, buzzer, LEDs as what? Output. Let me add that one here. So we also have a plus what? LED plus what? Buzzer. Okay, buzzer. All right. Now output unit, all for what? Detecting and displaying the temperature of an environment. This replaces traditional means of temperature monitoring, which involves regular human supervision, leading to human what? Errors. So let's look at the block diagram right here. This is the block diagram right here. So like I said, the temperature sensor powers the temperature sensor senses the temperature in the atmosphere, the temperature in the surrounding, and then send signal to the microcontroller. Of course, power supply powers the microcontroller, and then the microcontroller sends what? Output to the buzzer, liquid crystal display, and then the LED or LEDs. All right, so that's that. So the components include DHT temperature sensor, and then Arduino microcontroller, liquid crystal display, LEDs, buzzer, 9 volts battery as the power source. Okay, battery, and then wires, and then breadboard. So this is everything we made use of, or everything we can make use of as minimum. Okay, viable product. All right, then the connections. For the connection, the DHT, which is the temperature sensor, is connected to the Arduino analog pin. Why analog pin? Okay, because the temperature is an analog signal. Temperatures are analog signal. They are continuous in time. You always have temperature. There is no point in time where you have temperature, then temperature vanish. Even at 0 degree, that's a temperature. Even at minus, that's a temperature. That's temperature reading. Okay, so temperature is continuous in time. So therefore, for the Arduino to read it, it has to be connected to the analog pin. Okay, and of course connected to ground, and 5 volts pin in Arduino. So this guy has 3 pins that we are going to connect. What the output from this one, output from the sensor will go to what? Input of analog Arduino. Then the ground of this one will go to ground of the Arduino, and then the positive will go to the positive of Arduino. Then the LEDs, of course, green, yellow, red. Now we are using 3 LEDs. Okay, if the LED is showing green, meaning the temperature is at the certain level we want, it's okay. If the yellow LED turns on, okay, that's not too good. If the red LED turns on, brother, that means that means it's not good at all. It's high. Okay, and of course the buzzer, to the LED, buzzer, and the LCD are connected to the Arduino digital pins and ground. Now for the firmware, which is the software, the project for the system is written in C and C++. Of course, that's inside Arduino IDE. Okay, now the integrated development environment IDE used is what? The Arduino IDE, Arduino Integrated Development Environment. So it starts by initializing the variables to be used in the program, representing the components connected to the Arduino. Okay, and then the instructions are written to set up the Arduino in the way it is physically wired. And it's just like those videos we've dropped on before on programming the hardware. Okay, just like those programming we've done before. Of course, if you have question or you want any other clarification or things like that, put it in the comment section and we'll reply to that. Okay, then the next is the function, which contains instructions that will be repeated. That is a void loop. This part is the void setup. Okay, void setup. So a void setup here. Here initializing variables. Then this part is the void loop, just describing it. So which contains instructions that will be repeated by the Arduino. This includes instructions to read inputs from the temperature sensor, map and convert input signal to degrees, compare inputs to predefined values to determine input value that will be displayed. For normal temperature, that's green LED will turn on. For low temperature or high temperature, okay, now for normal temperature the green LED lights up, then yellow for low and red for high. Then the buzzer turns the buzzer also turns on for high temperature. All right, so I think this is the end. And the importance of this thing, the significance and application. The system integrates affordable components to achieve real-time temperature monitoring, which is vital for systems, machines, environments that require temperature monitoring that will lead to prompt response when there is need to adjust physical parameters or attend to devices that needs attention at certain range of time. Now, if I had enough time, I still have other past questions to work on. If we had enough time, we would have, tried to do this thing either by simulation or by physically building it. Okay, but of course, we hardly have time. Exam is so close. Okay, so that's why we just have to rush through this. So leave comments in the comment section, and then we'll see you in the next one.